Good day, everyone. And how is everybody doing today? I'd like to welcome everyone to today's class, which will be centered on Introduction to General Chemistry 2. Now, moving forward, this course unit 1.1 and 1.2 will be centered on Unit 1.1, Historical Survey of the Development and Importance of Organic Chemistry, while Unit 1.2 will be the nomenclature and classes of organic compounds. Now, moving forward, these course objectives are naming of organic compounds. That is, we have to name the organic compounds. The second, now moving forward, purify and quantify simple organic compounds. That is, we all know that nature itself is not pure. And we need to purify all the extracts we have gotten from nature and quantify them. That is, we have to know the amount of the extract we have gotten from nature of these organic compounds. Now, you have to draw the structure of organic compounds. That is, the organic compound you have to know and draw the structure. Identify saturated and unsaturated hydrocarbons. When we say saturated, it means the one that have a single chain. And when we say unsaturated, it means the one that have double bonds. Now, describe the periodic arrangement of elements. That is, you have to know how elements are arranged inside periodic table according to horizontally and vertically, according to the period and so on and so forth. Now, explain the structure of inorganic solids. Then, moving forward, you have to know how to mention the basic properties of selected metals. Also, describe the quantitative test for selected metals. Now, moving forward, this study session 1 talks about the historical background of organic chemistry and the nomenclature and classes of organic compounds. When you know how to define organic chemistry, which is the study of the chemistry of carbon compounds. Great scientists like John Jacob Berzelius, Friedrich Wöhler, Augustin Kekulé, Archibald Cooper, Alexander Butlerov, Gilbert Lewis, Linus Pauling, and so on and so forth, whose names are very numerous to mention, all worked tirelessly to bring organic chemistry to where it is today. You see, nomenclature and the classes of organic compounds. You see, nomenclature means how you have to name your organic compound using using a particular system. And as of today, the IUPAC system of naming organic compounds has been established and useful in naming organic compounds, and as well classification of organic compounds. Now, let's talk about the basic principles. The basic principles entails identifying the parent, the parent carbon chain, functional group, side chains, and so on and so forth, and how to count the carbon atoms using codes like met for 1, ent for 2, prop for 3, boot for 4, pent for 5, X for 6, etc., etc. Now, types of carbon-carbon bonds. This one means if you have a singular bond, then we are talking about alkane. If you have a double bond, we are talking about alkenes. When the parent chain has a triple bond, then we are talking about alkynes. Now, what will be the learning outcomes for this study session? The learning outcomes for this study session 1 should be that at the end of this session, the student should be able to at least define organic chemistry. When you are done with learning this session that we are treating at the moment, you should be able to define organic chemistry. And at the same time, you should be able to explain the origin of organic chemistry. That is, where is organic chemistry coming from? Now, you have to be able to understand the basic principles of naming organic compounds. That is, when you want to name the organic compounds, there are some certain rules and principles that has to be obeyed and followed. Then, name organic compounds from its given formula. That is, organic compounds has to be named from a particular given formula. You have to, for example, when you are being given a particular organic compound, you have to be able to name that particular compound when you immediately see the formula. Immediately you see the formula of the organic compound. you should be able to give it a name when you're done with these learning outcomes for this study session 1. Then you should be able to translate the name of organic compound into a structural formula. Now, after knowing the name of the organic compound, you should be able to draw the structure of the structural formula, the structure that will represent the formula of these organic compounds. And at the same time, you should be able to classify different organic compounds to where they belong to. Now, moving forward, let us define organic chemistry. Organic chemistry is the study of chemistry of carbon. And why is carbon singled out? It is because it has a chemical diversity that can never be rivaled by any other chemical element. Carbon's diversity is based on the following factors. Carbon atoms, and the factors are, carbon atoms have the ability to bond strongly with other carbon atoms. What that means is this, that is, carbon atoms to carbon atoms has affinity for each other to bond properly with another carbon atom. And the number 2 factor is that carbon atoms bond well with other atoms of other elements. That is, carbon atoms can bond with oxygen, can bond with hydrogen, can bond with nitrogen, can bond with other elements, various elements, at least at a reasonable strong bond. And the other 3, and number 3 factor is that carbon atoms make a large number of covalent bonds, which is true for valence electrons. That is, carbon atoms has an atomic number of 6, which means carbon atoms has a valence electron of 4 that can be used to bond covalently with other associating atoms around. Now, moving forward, organic chemistry is very important due to its versatility and application. One of them is in the pharmaceutical industry and also in the petroleum industry, and likewise in the energy industry. In view of this, organic chemistry has a great future ahead. That is, organic chemistry has a very promising future. It is generally applicable in the petroleum industry, in the pharmaceutical industry. That is, people that study biochemistry, they know quite well that they can easily switch to the pharmaceutical line. Now, moving forward, to name organic compounds, IUPAC, which is in the International Union of Pure Applied Chemistry, that is, IUPAC is the system that is generally acceptable to name organic compounds, which an IUPAC means International Union of Pure and Applied Chemistry. What are the basic principles? This entails a number of steps to be followed in doing this. Now, the first step is to identify the parent hydrocarbon. That is, whenever you want to name an organic compound, you have to know the parent name, the parent hydrocarbon name. Now, the second is to identify the functional group, and do this according to order of precedence. That is, after knowing the parent hydrocarbon, you try to identify any functional group that is attached to the parent chain, and you do this according to precedence. Now, you need to also determine side chains. Does the parent hydrocarbon chain have side chains that are connected to it? You have to determine that as well. That is, the chains that are branched from the parent chain. These side chains are known to be the branched chain from the main parent hydrocarbon chain. Now, also you will need to identify, or let's say determine, any functional group that is left. Now, also determine whether it is a double bond or a triple bond. Then the number of chain as well needs to be known. Don't forget to also know the locants. What are locants? Locants will definitely tell you or specify the position of substituents and bonds. That is, locants will identify for you or tell you the position of any double bond or any functional group or any substituent that is attached to the parent chain. Now, moving forward, let us talk about how to learn the counting of carbon atoms. You will need to learn them using some codes. like met for 1, et for 2, prop for 3, both for 4, pent for 5, X for 6, and so on and so forth. The type of carbon-carbon bonds, that is it a single bond, or double, or a triple bond? They can be denoted. They can be denoted by R for alkane, that is when it has a single bond. In for alkenes and alkynes, when they have a double or triple bond. Now, also, alkyl groups are generally formed by removing a hydrogen atom from one of the compounds, like alkane, to give an alkyl group. Now, you see, alkyl groups are formed when an hydrogen atom is removed from the parent hydrocarbon. For example, methane has 4 hydrogen atoms attached to the central carbon atoms. Now, when you remove one of the hydrogen atoms, it gives you'll be left with 3 hydrogen atoms attached to the central carbon. Now, the new compound form is an alkyl group. Now, the methane will change to methyl. Likewise, ethane, if you remove one of the hydrogen atoms, you'll be left with ethyl, and so on and so forth. Now, moving forward, to classify organic compounds, depending on how the arrangement of the carbon atoms in their structure, they can be categorized into 1, acyclic or open chain, and cyclic or closed chain. Now, moving forward, the acyclic can either be in the straight or a branch chain, and they are gotten from either animal or vegetable fats. That's where they are being derived from. The acyclic can be derived from animal or vegetable fats. So it means they are referred to as aliphatic compounds. For the fact that they are gotten from animal or vegetable fats, they are referred to as aliphatic compounds. While on the other hand, the cyclic or closed chain compounds has one or more closed chains or ring atoms in their structure. They are further classified as homocyclic and heterocyclic compounds. Now, this homocyclic or carboxylic compounds has entirely carbon atoms in it, with no other atom available in the ring skeleton. This can be further divided into 2 subclasses, and these subclasses are alicyclic compounds and aromatic compounds. Now, with this, I hope one way or the other you have been able to gain 1 or 2, 3 things, and when you further read on, you will understand perfectly what we are talking about, the origin and the naming of organic compounds. Thank you for your time, and thank you for listening.